You ever wonder about the magic behind your Wi-Fi or how your headphones just connect? It all seems so complicated, right? Well, what if I told you that everything from a satellite orbiting Earth to your Bluetooth speaker shares the exact same super simple blueprint? Let's dive in and pull back the curtain on the script that powers our entire connected world. All right, here's our game plan. First, we're going to uncover that one universal blueprint that every single message follows. Then, we'll get into the different styles of digital talk. After that, we'll look at the actual physical highways our data travels on. And finally, we'll put it all together and see how this whole system shapes the world you and I live in.
And this, right here, is the big secret. It seriously doesn't matter if you're sending a text or if NASA's getting data from Mars. Every single communication, no matter how big or small, follows the exact same 5-step script. It's kind of like the universal language of connection.
So, let's trace that journey step by step. It always starts with an information source. That's just the idea, the message. Then, the transmitter, like your voice or your phone, packages it up. That message then travels through a channel. That could be the air, a copper wire, whatever. The receiver, say your friend's phone, grabs it and decodes it, so it finally reaches the destination. They get the message. Idea, speaker, medium, listener, understanding. It's a pattern you're going to start seeing absolutely everywhere.
Okay, so once a message is on its way, it has to follow certain rules of the road. You can think of these as different styles of conversation. It's not just about what's being said, but how it's being said.
The first rule is all about traffic flow. Serial communication is like a single-lane road. All the data bits just line up one by one. It's simple, but it's super reliable, which is why things like your USB cable use it. Now, parallel, that's a multi-lane superhighway. Tons of bits travel at the same time. It's way faster, but really only for short distances, like from an old computer to a printer sitting right next to it.
Next up, we have to decide who gets to talk and when. Simplex is a total one-way street. Think of a radio station just broadcasting out. You can listen, but you can't talk back. Duplex is a two-way street. There's half-duplex, which is like a walkie-talkie. You talk, then you say over, then they talk. But full duplex, that's the goal. That's a normal phone call where you can both talk and listen at the exact same time without it getting jumbled.
So what language is the signal actually speaking? Is it analog or is it digital? An analog signal is this smooth, continuous wave, kind of like slowly turning a dimmer switch up and down. But pretty much our whole modern world runs on digital, and that's a signal made of these super precise on or off pulses, just ones and zeros. It's as simple as a light switch. It's either on or it's off, clean, perfect for computers.
And finally, how does the signal find its own space? A baseband signal is just sent out in its raw original form. But, to send a bunch of signals through the air without them all crashing into each other, we use bandpass. Think of it like giving every radio station its own unique number on the dial. This trick shifts each signal into its own little frequency slot, giving it a clear lane to travel in. It's the reason your Wi-Fi and the radio can work at the same time without any issues.
So, with those 4 ideas, we basically have a cheat sheet. Any communication system out there, from your car radio to the entire internet, can be described using these 4 choices. Is it serial or parallel, simplex or duplex, analog or digital, and does it use baseband or bandpass?
Okay, so we've got the 5-step blueprint for any message, and we have the 4 main rules for how it behaves. But that leaves one giant question. What are the actual physical highways these signals are traveling on?
And that brings us to the channels. These are the real-deal pathways, from the cables buried under your street to the invisible airwaves all around us that carry all this information back and forth.
Let's start with the wired stuff. You've got twisted pair. Those are the humble old copper telephone lines. Then there's the chunkier coaxial cable, the stuff that brought cable TV to our living rooms. And then the king of them all, optical fiber. This stuff uses pulses of light, which is why it's ridiculously fast. I mean, light particles have basically no mass, so they can zip through glass fibers way faster than electrons can push through copper. It's the backbone of the entire internet for a reason. And then you have the wireless world. And what's wild is that it mostly relies on one incredible channel: free space. Yep, just the air all around us. It's the exact same medium that giant satellites use to beam signals across oceans, that your Wi-Fi router uses to connect your laptop, and that your phone uses to talk to your earbuds. They're all just riding on the same invisible highway.
All right, now for the fun part. Let's take all these pieces, the blueprint, the rules, the pathways, and put them together to see how this actually works in the real world. Just think about the Wi-Fi you're probably using this very second. We know it's a digital system, right? It's speaking in ones and zeros. We know it's full duplex because you can download and upload at the same time. And we know it uses a wireless channel, the free space in your room. See? All those abstract ideas just snap together to perfectly describe something we use every day. And that is the ultimate takeaway here. There is no magic. From the simplest text you send to the most complex network on the planet, the system is fundamentally the same. Every message follows that blueprint, picks a conversation style, and travels down one of those paths.
So that leaves us with a really cool question to think about. That 5-step blueprint, it's not going anywhere. But as our world gets more and more connected and our demand for data just explodes, what's going to define our future? Will we be tethered by the mind-blowing speed of optical fiber? Or will we go all in on the absolute freedom of next-gen wireless that connects everything, everywhere? That's the chapter that's being written right now.